Hey everybody, this is the first lesson in our new unit, Unit 4, where we're going to be talking about triangles and triangle congruence. In this first lesson, we're going to be talking about isosceles and equilateral triangles. This should be a pretty quick lesson, pretty easy assignment to go along with it. Maybe a couple of challenging questions, but they shouldn't be too bad. In this lesson, you should be able to use the isosceles triangle theorem and its converse to solve problems with triangles. And then just kind of an overarching theme or objective in this lesson is to solve problems involving both equilateral and isosceles triangles. So the first thing that we're going to look at is just to kind of quickly review what an isosceles triangle is. So isosceles triangle is a triangle where two sides are the same length. So remember, we use these marks here, these red marks, as congruency. Those mean that this TU is the same length as TS. So isosceles is two sides are congruent. So again, those marks mean that they're congruent. So for example, if we said that ST was 45, we should also be able to say that UT is 45. So problems involving isosceles triangle, one looks like this, where here we have these two sides are congruent to each other. So it says if ST equals 7x minus 10, so I just wrote the 7x minus 10 in here. UT is 3x plus 26, so write it next to the UT. We want to find the value of x. So again, if we know that these sides are congruent, excuse me, that means that they have to be equal in length. So the setup is just to set them equal to each other. So our setup here would be ST equals UT, so that means 7x minus 10 equals 3x plus 26. So you're just setting them equal to each other, and then we're solving for x here. So we'll have 4x minus 10 equals 26, 4x equals 36, so that means x equals 9. If you wanted to take a step further, you could plug in the value of x to figure out what these are. 9 times 7 would be 63 minus 10, so this side would be 53. That means that this side over here would have to be 53 as well because they have to be congruent. Now, let's talk about the isosceles triangle theorem. So the isosceles triangle theorem says that when you have an isosceles triangle, meaning that when you have two sides that are congruent like this, then the angles opposite those sides are also congruent. So that means that this angle right here is opposite the side TU. So angle S is opposite the side TU. And then angle U is opposite the side TS. So because these sides are congruent, it means that those angles are the same measure. So angle S would be congruent to angle U. And we're going to just kind of work through a problem that involves this. So if we knew that these sides were congruent based off of these marks, we could say that if we knew this angle is 56, that means that angle U would have to be 56 as well. So that is the isosceles triangle theorem that just says when you have an isosceles triangle, the opposite angles, or the angles opposite those congruent sides, are also congruent. So in this type of problem, here we have an isosceles triangle. We know that because these sides are congruent. It says if angle S is equal to 5x minus 7 and angle U is 2x plus 14, what is the value of x? So again, because these sides are congruent, it means that the angles opposite of those sides have to be congruent. So angle S has to be equal or congruent to angle U. So that means that these expressions we're just going to set equal to each other and solve. So move this over here. So we would just set 5x minus 7 equal to 2x plus 14. And then we would just solve for x here. So subtract 2x on both sides, add 7 to both sides, divide by 3, so x should be 7. If you wanted to take this a step further, again, you could plug in our value of x into the equation. We would get 7 times 5 is 35, minus 7 is 28. So both of these angles should have an angle measure of 28 degrees. All right. Now, so again, the isosceles triangle theorem is the one that says because the sides are congruent, it means that the angles opposite those sides are congruent. The converse of this is going to be if you have a triangle where you know two of the angles are the same, it means that the sides opposite those angles are the same. So this is basically just kind of flipping the idea around where now we're using the angles to say that the sides are congruent. So in this case, we would be able to say that because these angles are congruent, these sides are congruent here. If they're congruent, they have to be equal in measure, so we set them equal to each other and solve for x. And if you want to pause this at any time just to kind of practice your algebra skills to work these out, would be a good idea. So here we would subtract 15x on both sides, add 17 to both sides, we'd have 24 equals 8x. So that means that x has to equal 3. And if we took this a step further, we could plug in 3 into both of these values for x. 3 times 15 is 45. 45 plus 7 is 52. So that means that the other side is 52 as well. Because of the isosceles triangle, you have two sides that are congruent. All right, so now we're just going to look at a couple examples real quick. You can pause these to try to test them out on your own. Might be a good idea, but we are just going to work through these together. So in this problem, example 1 says, in the triangle to the left, find the following. We want to find x. We want to find the measure of angle j. We want to find the measure of angle k. All right, so first of all, because these lines are marked congruent, that means that they are the same. So we can just set them equal to each other and solve it for x. So if we do that, it would be 8x minus 13 equals 5x plus 17. Subtract 5x, add 13, and then divide by 3, and you should get x equals 10. For angle J, because these sides are congruent, the opposite angles have to be congruent as well. So angle J would have to be 68 degrees too. And then finally, if we wanted to know what angle K is, well, this is still a triangle, so all of the angles should add up to 180. So we would do 180 minus 68, should be left with 44 degrees, so that's what angle K would be. All right, in example 2 here, says in the triangle to the left, find the value of x, then find all the angle measures in the triangle. So if we notice that these sides are congruent right here, because the sides are congruent, it means that the angles opposite those sides are congruent. So set those angles equal to each other, and then we're just solving for x here. So we would subtract 4x, add 33. So then when we solve this for x, we're going to have x equals 8. So if we wanted to find the measures of all these angles, then we have to take our value of x, which is 8, and plug it back in. So this would be 8 times 4, which is 32, plus 7 is 39. So this angle right here has to be 39, which means that this angle right here would also have to be 39. See how this works here. So with both of these angles being 39, if we want to figure out the last angle in a triangle, we just do 180 minus the two angles that we know. So 180 minus 39 should get you the remaining angle, which should be 102. All right, and then the last example we're going to take a look at. This is going to be more of a word problem, so you'll see a couple of these on the assignment. So it starts off, it says, in triangle RST. So right away, just by this very first part where it says in triangle RST, if we don't have a picture, you should be able to draw a picture. And it doesn't matter how you label the triangle, any way that you label it, you should still be able to interpret all of this information the same way. So like if S was up where the R is at, and T was right here, and R was right here, it doesn't matter where your letters are at, just as long as you follow the rest of the information accurately. So if we know then that RT, so this side RT, is congruent to ST, ST is this triangle, or this side, it means that those two sides are congruent, so you can mark those as congruent in length, like that. So for these problems, I highly recommend drawing the triangles out because it'll help the visualization, and the problem should go by faster if you draw it versus not drawing it. Then, because we know that these sides are congruent, the Isosceles Triangle Theorem says that the angles opposite of those congruent sides are also congruent. Whoops. Meaning that, let me go back a little bit, meaning that angle R and angle S are going to be the exact same measure because they're opposite the congruent sides. The rest of this here is just filling in the expressions for all these expressions they gave. So 9x plus 2 is this angle R. Angle S is 13x minus 18, so I can write that there. Angle T is 17x plus 1. And what we're going to do is find the x of each measure, or find x and then the measure of each angle. So again, recall that if we have angle R and angle S congruent to each other, that means we just set them equal to each other. So let's read that quick. I'm not sure what's going on with this recording software. So again, we would take 9x plus 2, set it equal to 13x minus 18. We would then solve for x here by subtracting 9x on both sides. And solving for x, we should get 5 here. All right. And then if x equals 5, we can go ahead and plug in the values of x into all of these to figure out what each angle should be. So for angle T, we would take the x, plug it in. It would be 17 times 5 plus 1 is 86. For angle S, it's going to be 13x minus 18, so plug in 5 for x. 13 times 5 minus 18, and it should be equal to 47. So this angle right here is 86. This angle right here, angle S, is 47. Remember that angle R and angle S should be the same because they are opposite of those congruent sides. So this is isosceles triangle, so these angles should be the same. So angle R should also be 47. If you wanted to check it, you could do 9 times 5 is 45 plus 2 should be 47. All right, so that's it for this part in the lecture. There's going to be one other short video in addition to this where we just talk about equilateral triangles real quick.